All right, so this question that I have for you guys is actually from a diploma, and it's one of those released items, actually. So once again, this is a second degree trig equation, and this time we actually want to find the general solution for this equation. So we want to state all possible solutions here, but we are still going to use that unit circle to figure out where these solutions are in the first place. So first thing I want to do here is actually isolate the tan theta ratio. So to do that, I'm going to bring that 1 over. So I get tan squared theta is equal to positive 1. And then to get rid of the square, we go ahead and take the square root of both sides, but we have to consider both a positive and negative case. So therefore, tan theta, we actually have two equations here, is tan theta is equal to positive 1 and tan theta is equal to negative 1. So you want to look where on the unit circle is y over x equal to 1 and y over x is equal to negative 1. So we're actually going to have the same coordinates for each angle, but specifically for this case right here, we're actually going to have one is going to be positive and one's going to be equal to negative. So let's just treat each equation individually and solve, and we'll figure out a general solution once we could identify all solutions between 0 and 2 pi first. So for example, for this equation here, we find all angles in which the ratio y over x is 1. So tan is going to be positive in two quadrants here. So we're going to use add sugar to coffee here to find out. We have an angle in the first quadrant and an angle in the third quadrant. So you'll see that when tan is equal to 1 is when x and y are exactly the same coordinate, because when we divide them, we get 1. So a first solution here is going to be pi over 4, and then the second solution is going to be 5 pi over 4. Okay, so that's only within the first, that's only within 0 and 2 pi. All right, so remember, we're trying to state the general solution here. So I will highlight these terminal arms first before I move on to the next set of angles here. Okay, and then we're going to go take a look at the second equation, which is when tan theta is equal to negative 1. So tan is negative in quadrant 2 and in 4. So once again, y and x have to be the same coordinate, but they have to be the different signs. So that's going to occur at two places, one at 3 pi over 4. So that's my terminal arm there, and another one at 7 pi over 4. Okay, so as you can see here, you can see that our solutions are occurring here, and then next here, and then over here, and over here. Okay, so you get the idea. It's definitely periodic. So we want to state a solution here, a general solution. So let's say we start with the angle in quadrant 1, so pi over 4. That solution is going to repeat itself every pi units. So here is the first solution, then it repeats again pi units later, and then pi units later again, and again, and again, and over again. Okay, so here we have for the first general solution, we have pi over 4 plus multiples of pi, and to show multiples we multiply by variable k, where variable k could be part of the integers, because we can not only go in the counterclockwise direction but also in the clockwise direction. So that takes care of those solutions, but we also have solutions in quadrants 2 and 4. So looking at this solution, for example, that's going to repeat itself every pi radians. So it repeats itself here, and again here, and over, and over, and over, and over again. So to state that the next part of our general solution, we have 3 pi over 4, and we're adding multiples of pi radians. And to show multiples, we use k, where k can be a member of the integers because we can go in the clockwise direction as well. And that's how you do that question.